Yes, I can. Hi, guys. Today we'll be talking about dynamization. So, how do we define dynamization? It is the intentional alteration of a fixation construct to increase the micromotion at the fracture site, which stimulates secondary bone healing. So, secondary bone healing is nothing but the healing at the fracture site, which occurs with the help of callus formation, whereas primary bone healing occurs without callus formation. So, by dynamizing, we are aiding in the formation of the callus. So, how do we dynamize a construct? So, we can dynamize an external fixator, we can dynamize an internal locking nail as well. So, how do we, for example, how do we dynamize an external fixator? Anything that reduces the stability of the construct slightly to promote callus formation at the fracture site is a form of dynamization. So, for example, we know that the greater the number of connecting rods used in an external fixator, the more is the stability. So, if we remove off a connecting rod, it's equivalent to dynamizing the external fixator. So, how do we dynamize a locking nail? So, to dynamize an intramedullary interlocking nail, we have to remove a screw from the static hole. I'll show you what that looks like in the next slide. So, what this does is it leads to axial loading and micromotion at the fracture site, which promotes callus formation. So, this is an example of a femur nail. As you can see, there's 1, 2, and 3 circular holes, and there's one oval hole at the top of the nail. These circular holes are nothing but static locking holes, whereas this oval hole is a dynamic locking hole. Okay, just keep that in mind. Coming to the next slide, you can see they have removed a screw from one of the circular holes of the static locking hole. And if you look at the previous image, we can see that there's this much. The static hole fits the entire screw, whereas if you put a screw in the oval hole, we can see that the screw can move up and down quite a bit if there is nothing stopping it from moving. Okay, so what I mean by that is they've removed a screw from the static locking hole. So, and we can see that there's still a screw remaining in the dynamic locking hole of the nail. We can see that there are still two statically locked screws in the distal segment of the bone, whereas there's only one dynamically locked screw in the proximal segment of the bone in the nail. So what happens is, since this is dynamically locked, there's the length of the oval slot in the nail, the screw can freely move. Okay, this much the screw can freely move. So what happens is, whenever the person puts weight, since this segment is fixed and this much movement is allowed, the screw can move from top to down here. So as you can see, it's moved from the top position of the oval slot to the bottom position of the oval slot on loading. So what happens is, this entire lower segment moves upwards and creates a compression at the fracture site. So this is what we mean by dynamization, and repeated loading over a period of time. So the more and more a person walks with this dynamized construct, it increases bone contact and chances of healing. So this is another example. We can see that this is statically locked, this is a static slot, and this is a dynamic slot. So we can see that the dynamic slot, the screw is placed at the top part of the hole away from the fracture site. So if we place a dynamic slot here, imagine there's a dynamic slot here, it should be in the part of the hole away from the fracture site. So what happens is, if we remove this static screw construct, which is the top one, we can see that this becomes a dynamic segment, and so whenever the person loads, this statically locked construct will move upwards and create compression of the fracture site when this static locked screw is removed. So what this does is, once the statically locked screw is removed and only the dynamic screw is there, it creates telescopic movement between the nail and the bone, and closes any gaps which were there and creates continuity in the bone, and also improves the callus formation. So this repeated cyclic loading due to free axial movement closes the osseous gap at the fracture or the non-union site, helping in the process of healing. So the effects are, it induces new bone formation, promotes callus maturation, and promotes faster callus remodeling. So the main indication of dynamization is delayed union with biological activity. So if the fracture site does not have any biological activity, it's an atrophic type of non-union, we can still dynamize, but we'd have to additionally put bone graft. But if the biology is already good, all we have to do is dynamize and the fracture itself will heal. So, bone is biologically active, but the mechanical environment is too rigid. So, by removing the statically locked screw, we reduce the rigidity of the construct, which creates micromotion at the fracture site, which in turn aids with callus formation, which in turn aids with fracture healing. So, this is how it works. And also, when do we dynamize? The timing of dynamization is very important. We should wait till there is some evidence of callus, and then once the callus stops progressing, that is the ideal time to dynamize. When is it a bad idea to dynamize? When there's infection or there's a comminuted fracture pattern, we do not, it's better not to dynamize, and it's better to let it heal naturally. And do not dynamize too early, as if we if the construct stability is compromised too early and it becomes too less stiff too early, and there's too much micromotion, this in fact can hinder callus formation. That is why it's better to dynamize after there is some callus formation and there's some stability across the fracture site. So, if there is no progression after 6 to 8 weeks of dynamization as well, what we have to do is we have to consider something called an exchange laning, where we remove the thinner nail, ream, increase the canal diameter, put a thicker nail, and in addition to that, put bone graft at the fracture site. So this is what is done if there is no callus despite dynamizing for 6 to 8 weeks after dynamization. This is an example of a case. The first X-ray with label D shows the fracture site 16 to 18 weeks after the procedure. As you can see, there is some callus formation, but it's not adequate. So this construct was dynamized, and you can see this is after the dynamization procedure. You can see the static screws are removed, and you can see there's only one screw in the dynamic slot. So you can see 4 weeks after dynamization there is some significant callus formation, but a total of 18 weeks after dynamization, which is the figure F, we can see that the fracture site is completely healed and it's been bridged, and in fact there's excess callus formed, and after that the nail can be removed. So you can see this is the dynamic slot and these two are the static slots. If you guys have any other topics that you want me to make a video on, let me know in the comment section and I'll do it. Cheers and thank you.